Okay, before I start showing you how to find the average rate of change, I want to make sure that you have a completed table graph and that you have answered part C correctly. So first of all, look at your table. You should have a parabola that is facing downward with a table that starts at 0, 5 and ends at 5, 5. You should have a vertex that has the highest point at 2.5 and 105. So if that is not the case, I want you to go back and re-look at your numbers and fix it, because in order for you to get your intervals correct, you have to have these numbers correct. Okay? So I am going to be going on to part D. They are asking you to complete the table to find the average rate of change for each interval, and I'm going to show you how to do that, which is actually really simple, but I'm going to do a couple of examples for you. So for example, on the first one, when it says 0 to the 0.5 seconds, okay? If you look at your table, it should have 5, and then you should have gone to 41 feet. So what you were supposed to do to find the average rate of change interval is you do 41 subtracting 5 over 0.5 subtracting 0. So in other words, 36 divided by 0.5, which gives me the rate of change at 72. And that's what you put in that box. Okay? For the next one, when it says 0.5 to 1 second. If I look at my table, my 0.5 again, it was at 41. And then it went 1 second, it was at 69 feet. So when I go over and do my rate of change, I go 69 subtracting 41 over 1 minus 0.5. Okay, so you guys can see the pattern. So 69 minus 41 is 28. Again, you're going to be dividing by 0.5 because that's what we're going up by every single time. And that's going to give you 56. Okay? You're going to do this each time for the time intervals on the rest of page 235. Now, when you get to the second row, where you're now at 2.5 to 3 seconds. Remember, if you look up at your table and at your parabola, your time is starting to go down, or I should say your parabola is starting to curve downward. So let's take a look at that. From 2.5 to 3, we go from 105 to 101. So we are subtracting 101 minus 105 divided by 0.5, which is going to give you -8. Now, we expect a negative number here. See, as the parabola is going up, we expect positive numbers. As the parabola is going down, on this entire row, you are going to see negative numbers. I want you to go ahead and fill in the rest of these tables, and you should be expecting increasingly bigger negative numbers as you fill in the rest of this table. Then I want you to go ahead and turn to page 236, and we're going to answer the questions on the top of the page on numbers 1, 2, and 3 together. So number 1 says, compared to the average rate of change of a linear function, what do you notice about the average rate of change in part D of activity 1? What you should be noticing is the rate of change is not constant, it is decreasing. Number 2 says, is the average rate of change increasing or decreasing from 0 to 2.5 seconds? How can you use the graph to justify your answer? Well, if you look at your graph or if you look at your table, you can see that it's decreasing. It goes from 72 feet per second to 8 feet per second. So write that down. It's decreasing. So 72 feet per second to 8 feet per second. Number 3 asks, what do you notice about the average rate of change when the function is increasing and when the function is decreasing? Well, it's pretty simple. When it was increasing, you should notice that the rate of change is positive. And so the converse of that is true. When it is decreasing, the rate of change is negative. Now, if you look below in example number 4, you are going to basically be doing the same thing, except you're looking at a table where you are only going to be graphing half of a parabola and then making some observations about what happens in the ordered pairs and the curve through the points when the function is increasing and decreasing only when we look at positive numbers. So I want you to go ahead and finish up by answering question number 4 and making sure that you have completed questions from 236, 237, and 238.